Now we get to learn how to write instructions. First of all, instructions have four fields separated by spaces or tabs. These fields are the label field, the opcode, which, as the name implies, it's operation code, operand, and then the comment. Remember we explained a couple of lessons ago op and operand. We said that the operand in mathematics is the quantity on which an operation is performed. So the opcode is the operation code, the operand is that quantity, and we can put a variable in place of this quantity. The quantity necessarily does not have to be a number. So we have the label, the opcode, the operand, and the comment. Two of these fields are optional. You don't always need the label and you don't always need a comment, but it is good programming practice and it increases readability to have all of these four fields. Let's take an example. Let's say we have init move r0 150. Init here is the label for the instruction move r0 150. What we could use the label for is to call this instruction. We could jump to this particular instruction by invoking the name of the label. That is one of the uses of the label. And move here is an operation. We have so many operations, we'll talk about them. And the operand here is r0 150. What this does is it just puts the number 150 in the register r0. This is a very basic instruction. Now let's explain the meaning of each field. Over here we have the label field, and as we mentioned earlier, it is optional. It is used to find the position of current instruction in memory. That is why we can use the label field to jump to a particular instruction, because the label field finds the position of that instruction. The opcode specifies the processor operation to perform. This one specifies the operation to perform on the operand, which is followed here. The operand usually specifies the source and destination of data to be processed by the opcode. So the source here could be a number or it could be a register. And comments are optional. They are used to explain code meaning. Now, the next thing we are going to talk about are processor directives. They are not instructions per se, but they perform certain functions similar to instructions. They assist the processor in doing various tasks. And one of the uses of these directives, which we would give some examples later on, are they assist and control assembly process. They are also called pseudo ops. They are not part of the instruction set, as we mentioned earlier. They change the way the code is assembled. So as we said, these directives that we'll talk about next, they are not instructions, but they affect the compilation and the way the code performs in various ways, and they are necessary for the compiling and running of programs.